we have our first online quiz, class test 1, right? Our first online quiz, class test 1, will be held on Sunday, 7th March. Exam duration will be 20 to 25 minutes. Then syllabus will be section 1.1, 1.2, 1.3 of chapter 1, and type of questions I have already discussed in the last class. But those who joined new today, please be informed that our first online quiz, that is on ELMS. So you have to ensure you have access to ELMS. You have enrolled in this course, and then the exam will be activated from 12:15 p.m. Okay, and the exam duration will be, as I said, 20 to 25 minutes. So you have to start the exam by 12:15 or maximum 12:20, and then you will have the allocated time. Type of questions will be mostly MCQ, multiple choice questions, matching questions, true false, and 1 or 2 short questions where hopefully we will not need to write more than 3 or 4 lines of text in the text box. Any question on that? Okay, fine. Then we have covered the syllabus in the last class, 1.1, 1.2, and 1.3. Just one particular example we were not able to complete. We will complete it today before going to the next section. Okay. So what we have covered in the last class, section 1.1, that is what is the internet. Just a little review. We said that there are 2 types of view if we see internet from top. One is nuts and bolts view. That means different components, both hardware and software. Like for hardware components, those can be end systems, those can be intermediate devices, end systems like PC, laptop, server, smartphone, and intermediate devices like routers, hub, base station, wireless router. Okay, those connects end systems. And software means like our browser, operating system, Windows, Linux, then different protocols like HTTP, SMTP. And then another view is the service view. So if I say okay, what kind of service we get from internet irrespective of any particular hardware or software. So there are 2 types of services. One is reliable. For example, file transfer, where no data loss is tolerable. You have to get 100% data without any loss. And there are unreliable services. For example, voice, VoIP, right? Instant messenger. We use Skype, or multimedia like video streaming. So this kind of services internet provides us through unreliable service, where delay is more important than some kind of data loss. So these were 2 top views. Then we have defined what is a protocol. Okay, any question?
There is a question regarding on this in study guide, sir. 2 types of internet service. Are these reliable and unreliable?
Unreliable. Yes, these 2 types of internet services means actually service view of internet, same thing. Any application you find in internet, any application like web browsing, like file transfer, like VoIP, okay, like video streaming, any application must be within these 2 categories. Either it will be reliable or it will be unreliable. Okay, we'll go to more details on these on chapter 3. When we go chapter 2 and 3, when you go application layer and transport layer, more details. Then what is a protocol? We know everything in networking is actually governed by protocols. For example, you are very much aware of HTTP, like all of us continuously using HTTP. When we browse. So we see HTTP or HTTPS on the left. That is an example of a protocol, but there are many protocols, and without protocol, networking will not work. So we have defined protocol using 3 keywords. Just don't need to remember the entire definition. Just keep in mind there are 3 keywords that actually defines a protocol. That is format, order, and actions. So format and order is related with a message. Format means what kind of fields will be there, and order means which will come first, which will come later. Like I said, in case of language, like I eat rice. So in case of English, first subject, then verb, then object. In case of Bengali, there are other rules. So format and order defines a message, and also very important, what to do when you receive one correct message. If you receive a message correctly, what to do, right? So that are also defined in a protocol. So basically 3 keywords. When you remember, when you understand these 3 keywords, you will understand what is a protocol. Then we have covered section 1.2, that is network age. What is network age? Anyone? Shifa?
Sir,
Are you
end
there?
devices.
Shifa Chaudhary? Okay, I'll ask just a specific student. Okay, Shifa Chaudhary, are you there? No? Misbahul Alam? Misbahul Alam. Okay, Yasir Arafat?
Sir.
Okay, tell me, by
Sir,
using
can you-
2 or 3 keywords, what actually contained in the network age?
Network is.
Yes, what is network age? Or
Sir,
what devices actually constitutes the network age?
sir, basically, sir, and there are 2 parts in network is, right? Network is a network core.
Right, but what is network age? That was my question. Just make it simple. What are the devices?
Sir,
that we found in
our
network age?
mobile phone laptops is also part of our network is.
Right. Right, correct. But these are all end systems. So when
Is
you
this
say
a-
what is network age, all end systems are in network age. There is another specialty of network age, that is whenever we use some applications, then definitely we communicate in the network age. That is, our own device is part of the network age, and the other device, whether it is Facebook server, whether it is Google server, whether it is Yahoo server, that is also part of network age, right? So network
sir.
age
Yes.
contains applications, and then the intermediate devices actually connects the network age to communicate data. Okay, so there are 3. When you go to more in depth, that is section 1.1 says from the top, and now we are going in depth. Then we can divide internet into 3 different structures. One is network age, that constitutes the that consists of end systems or hosts, and then network core, that consists of intermediate devices, and then the third one is physical media and network access. So in case of network age, we have 2 types of architectures. One is called client server architecture, like web browsing, email, FTP, DNS, and another architecture is peer-to-peer architecture, like when you connect a number of devices using a hub or switch, then any device can act as client or server simultaneously. So this is the basic concept about network age. We will go through more details in chapter 2 and 3. Then network core. So section 1.3, that actually describes network core, that consists of intermediate devices. And then the third part is physical media network access. Physical media is how the devices are connected, and network access defines what are the ways we can connect to internet. Okay, so different ways we can connect our devices to internet. So these are actually the structure, more in-depth structure. Any question up to this point? Okay. Mahfuzur Rahman Sifat. Mahfuz, are you there? Mahfuzur Rahman Sifat. Mahfuzur Rahman, are you there?
Yes, sir.
Okay, did you get my invitation? Email?
No, sir. No, sir.
Did you complete registration?
Yes, sir.
When?
2 days
Yesterday or before? What is your ID? 182-058?
181-274.
Okay, 181 181-274. Okay, so you are there. I think I have already sent you the invitation. You did not actually accept the invitation. That's why you need permission every time you enter the class. Go to your email and then check the invitation and accept. Click yes. Okay.
Okay, sir.
Okay.
Sir, I have a question, sir.
Okay, Rohim. Okay.
Is server is called intermediate device?
No. Server is actually end device.
End device.
End device. Because what is end device? Just make it a simple. Make it very simple. Whatever is at the end of the internet, that is end device. You will never get a router or switch at the end. Definitely, why we use router or switch? To connect devices, right?
Yes,
So
sir.
devices will be end. So similarly, server will be at the end of the internet. In that way,
সার্ভার তো অ্যাপ্লিকেশন এক ধরনের, তাই না?
what is that? Server?
স্যার সার্ভার কি এক ধরনের অ্যাপ্লিকেশনই বলতে পারি না আমরা?
Application?
ইয়েস স্যার, কারণ
No.
কম্পিউটারে
Service is application, right? Service is application. Server is who provides service. So server is actually host or device or a physical device that contains the software. That software is service.
তাহলে স্যার মানে সার্ভিস মানে সার্ভারটা আমার অ্যাপ্লিকেশন না হয়েও ও হচ্ছে এন্ড ডিভাইস।
No, server provides application, fine. Server is part of the application, that is fine. But application is connected with end device always. So server
Yes,
is
sir.
also end device. Because
Okay,
when you connect to facebook.com, right? Where is facebook.com? Facebook.com is at the other end of the network, right? That is a physical server. There are hundreds of physical servers, but all servers are at the end.
Yes, sir.
ওকে স্যার, ইয়েস স্যার।
Okay, thank you. Okay, so section 1.3, that is network core, that actually consists of intermediate devices. What is the purpose of network core? To connect end devices. So the purpose of network core is to connect end devices. What actually, where the end devices reside? In LANs, right? Local area networks. So when we connect the LANs, we call that WANs, wide area network. And actually WANs consists of network core. WANs are more connected to network core. But basically the definition you can see like that in the last class I have shown you. So all the intermediate devices will fall into the network core, right? As shown in this diagram. Okay. So that was actually we have covered in the previous class, and we also discussed about two technologies is network core. One is circuit switching and one is packet switching. And we have already covered the circuit switching concept. Example is traditional telephone network or the mobile cellular network, 2G, 3G, and different technologies like FDMA, TDMA. FDMA means frequency division, multiple access. That means we divide the frequency resource into smaller pieces TDMA means time division. We divide into the time. Our CDMA is code division. That means all frequency and time we use, but we use different codes for different users. This is CDMA. But basically in circuit switching, the resources are dedicated to the user. That's the main problem. So what we saw in the last class, some properties of circuit switching like dedicated resource, fixed users, and less utilization. I am not going to very detailed today, but these already we have covered in the last class. And then in packet switching, there is no dedicated resource. That means all resources are shared. And for that reason, number of users are theoretically unlimited. And definitely there will be more utilization. Although if you increase the number of users, your probability of getting 100% service will decrease. How? That is what we have started in the last class, but we could not finish. One example, that is exercise 6. The example of packet switching is internet. For example, web browsing, email, Skype, torrent, all are application of internet. And then we have started one exercise in the last class, that is the exercise 6. Just let me start from the question again. So there is a link, common link. The capacity is 200 megabits per second. Okay, and if you use circuit switching, then suppose number of users supported will be MCS. If you use packet switching, then you can see users data will be divided into packets, and in that case just assume number of users will be NPS, but the capacity of the link will be same. Now there were two information given in the question. Each user requires 25 Mbps, megabits per second, and another information, only each user only needs to transmit 20% of the time. That means what? That means each user is idle for the rest 80% of the time. So as we said in the last class, in case of circuit switching, this doesn't matter whether a user uses 10% of the time or 100% of the time. The resource is dedicated to the user in the entire time. So that is what the disadvantage of circuit switching is, less utilization, because even if that is idle, you cannot assign that resource to another user because resources are dedicated. Okay, but in case of packet switching, resources are shared. So if someone is not using the link, then others can use the link. So let us see, using a numerical example, how packet switching is better in terms of utilization and number of users. So the first question we have already solved in the last class, very simple. When circuit switching is used, what is the maximum number of users that can be supported? Since every user requires 25 Mbps, right? So just divide that entire bandwidth with 25. So total bandwidth was 200 and each user needed 25 Mbps. Just divide, you get number of users, number of maximum users. You can say this is maximum number of users. Okay, so that is 8. Any question up to this point? This is very simple. Doesn't matter 10% or 20% of the time it is used by the user, rest of the time it is idle. Now we actually started this but could not finish. What says in the question? For the remainder of this problem, suppose packet switching is used. When you use packet switching, first thing you have to keep in mind, there is no maximum number of users. Why? Can anyone say why? Nibirujjaman Nibir, are you there? Nibirujjaman Nibir, Sadman Shakib. Sadman Shakib. Adnan Kabir. Taki Yasir.
Yes, sir.
Okay, Taki, can you tell me why in packet switching number of users not fixed?
Because packet switching is not use number of ports for switching, like circuit switching.
Right. So that means it is not dedicated. The main thing is resources are not divided and dedicated, right? If you divide the resource, that means doesn't matter how large bandwidth you have, you will have fixed number of users because you have to divide into number of users. In case of packet switching, there is no dedicated resource, and that's why anyone can use the network. But what can happen if many users use the link simultaneously? Then delay can be more, then there can be traffic jam, like congestion can happen. Okay, we'll see it later. So when we say packet switching is used, since it will not actually restrict on number of users, what you have to do if you want to show what is the effect of number of users, you have to assume number of users. So in this question, first let us assume we are using 15 packet switching users. So NPS equals to 15, right? Just let us assume this, and based on that, answer the following questions. Okay, first question: can these many users be supported under circuit switching? Shahadat Hussain. Shahadat. Rakibul Islam.
Sir, Shahadat.
Oh, Shahadat. Okay, can you tell me, can this many users be supported under circuit switching? Yes or no?
Yes, sir.
Supported?
Yes, sir. Supported.
So packet switching can support 15 users. Sorry, circuit switching. Circuit switching can support 15 users.
No, sir. Circuit switching. No,
Right.
sir.
Circuit switching cannot support. Now it says explain. How you can explain that? Any idea?
স্যার মানে সার্কিট সুইচিং এর তো ব্যাপারটা হচ্ছে ডেডিকেটেড, আর যেহেতু ডেডিকেটেড আমার যেহেতু 200 এমবিপিএস আছে, সো আমার এট মোস্ট 8 জন ইউজার আমার একসাথে ইউজ করতে পারবে।
Very good, very good, very good. Okay, fine. So if I say, okay, for I can say like this way, right? For 15 users, we need
25 into
right
25 into
25 into 15. Very
Yes,
good.
sir.
25 into 15. That means it is, I think, 375 Mbps, right? Mbps, which is much greater
more
than the
bandwidth.
given 200 Mbps, right? So, right?
200.
Right, 200 Mbps.
Sir, could you just explain me this part again?
Okay.
Like this 200
Okay,
Mbps.
okay, thank you, Shahadat. I think how to explain. Okay, the main thing is, you know, in case of circuit switching, irrespective of percentage of time user is transmitting. Okay, what is the bandwidth we need? See the question. Each user requiring bandwidth of 25 Mbps. So now assume we have 15 users. So how much bandwidth we need?
375, sir.
Right? So just 25 for one user. If we want to support 15 user, we need to multiply. Simple. So we need to have 375 Mbps, right?
Yes, sir.
Ashrafun, is it clear?
Yes, sir.
Okay. So, but that we have only 200 Mbps. So that was the question, whether this can be supported by circuit switching. No. But it says explain. How you can explain? Just show me, if we need to support 25 users, 15 users, we need to have this, but we have only 200. So that is the explanation. Is it clear?
Yes, sir. But I didn't understand why there is double greater sign.
Oh, okay. That is much greater than I just. Okay, you can write like this way. Okay, which is which is much larger than the given bandwidth. Okay, you can write like this. Then
Okay,
the
sir. Thank you,
given,
sir.
okay, the given bandwidth 200 Mbps. So you can like this. It is your choice how you can actually explain, but this is one way. I showed just one way how we can explain. So our answer, first answer is no, and then we can just explain in this way. Okay.
Sir, can we write it in the exam as well? Write that much larger in the sign form?
Yes, yes, you can. Just you need to make me understand. Okay. If I know, okay, if I am sure that you have understood the thing, your explanation actually represents that, then it's okay. Doesn't matter you write 2 lines, 3 lines, 4 lines. It is not mandatory. Okay.
Okay, sir. Understandable.
Okay, thank you.
স্যার
Now, yes.
স্যার আমার একটা কোশ্চেন আছে।
Okay, Taki.
কোশ্চেনটা হচ্ছে স্যার যে আমরা তো স্যার সার্কিট সুইচিং এ ডেডিকেটেড কিছু লাইন দেওয়া আছে যার কারণে আমরা নির্দিষ্ট পরিমাণ ইউজার ইউজ করতে পারছি, কিন্তু প্যাকেট সুইচিং এ তো আর এইটা দেওয়া নেই। তারপরেও স্যার বেশি ইউজার যখন হচ্ছে তখন কিন্তু প্রবলেম করতেছে, কিন্তু স্যার এটা কেন?
Right.
কারণ
Right.
প্যাকেট সুইচিং এর কি নির্দিষ্ট সংখ্যক ইউজারের পরিমাণ কি আছে নাকি স্যার
Right,
এটা
right. Okay, Taki. Okay, good question. Good question. Thank you. Actually, I am coming to that. Okay, now our next 2 questions, I think your confusion will be much clear, because so far we dealt with only circuit switching. And when we say circuit switching, fixed number of bandwidth, fixed amount of bandwidth. Now, when we use packet switching, what is the idea of packet switching? The idea of packet switching is like this. No link is divided and dedicated to user. Then how many users can use the link? Every user's data will be divided into a number of packets, and then the packets will be sent to the device. For example, this is a router. So what router will do? Router will store the packets according to the arrival time, arrival rate, arrival time. So the packet coming first will be sent first. Doesn't matter whether it is A or B. So there is another I think another keyword will get in case of packet switching. In case of circuit switching, this is fixed pattern. Sorry, this is fixed pattern. That means fixed pattern means what? Fixed pattern means in FDMA, TDMA, CDMA, if you see the picture, you can see a user will get a particular pattern, fixed pattern, right? In case of TDMA, see 1, 2, 3, 4, then 1, 2, 3, 4, then 1, 2, 3, 4. So after every round, one will get again 1 slot, right? But maybe in that slot, one is not transmitting. Is it clear? It can happen in the second slot dedicated to one has no data to send. Eta ki hote pare? Yes or no?
Yes, sir.
It can happen because when we talk, right, we don't talk 100% of the time. Even both sides are not using 100% of the time for talking. There are some time when both are thinking, both are like taking time. For data, that is also true. You have unlimited connection in the home, right? Many of you have taken unlimited internet connection. Do you use 24 hours a day? Even if you use 24 hours a day, your machine is not using internet 24 hours a day. You are reading a paper that is downloaded. When it is downloaded, you are reading the paper, it is not sending anything. So keep in mind, we are not using 100% of the time. That's where internet, actually in case of internet, the usage pattern is different. So that's why packet switching is much better for internet. So this will be now clear if we go to these answers. Okay. Now, how can we represent this? That is the point. Like Taki asked the question, in case of packet, actually the same thing happens in case of packet switching also. If in the system there are 8 users maximum, think we are using packet switching and there are 8 users in the system. Will it be any delay, any problem? Every user should get 100% service, right? Because if all the users are using 100% of the time, even then we have enough bandwidth. Is it clear?
Yes, sir.
Right? 8 into 25, 200. So doesn't matter if everybody is using 100% of the time, even then no problem. But what happens after 8? When number of users
There would be
are
problem.
getting more than 8. Right, there will be problem. What will be the problem? The problem will be not everybody will get 100% of the service. There will be some deterioration of the service that we have to accept in case of packet switching. Like in our Wi-Fi, right? UIU, in Wi-Fi, there are 50 users per floor assigned. Bandwidth is assigned according to that. If they increase 50 to 100 without increasing the bandwidth, what will happen?
Lagging?
Everybody will start getting, right, everybody will get getting its long delay, not getting the satisfactory service, because the bandwidth kept the same, but number of users will increase. Same thing happens when you use some internet connection from some company, and then they actually increase number of users without increasing the bandwidth. Okay, so that is about packet switching. Now, theoretically, how we can deal with that? Using what? Probability. So that's where we have started in the last class. Okay, in the last class, we started packet switches uses binomial distribution. So in statistics and probability, I think you have already learned about binomial distribution. That is NCR, P to the power R, 1 minus P to the power N minus R. Is it clear to everybody? I am writing this in a text box, so that may be a little bit difficult to understand, but I think you all know this formula. Just the logic. Let me clear the logic. Here, N is total number of users in the system. So in our case, what is that? 15, right? Then R, according to the formula, R indicates number of users actively using internet, right? Or actively transmits data. Is it clear? Now, each user actively transmits data. What is the probability in our case?
0.02, 20% 0.2.
0.02.
Right, 20% means 0.02. So see, this information now will count in packet switching. It was not counted in circuit switching. That was the problem. Now, if you say, okay, according to the real scenario, everybody is using 50% of the time, that means there are more probabilities of utilization of internet. The more percentage a user will use, the more probability that the demand will be higher, and the more probability everybody will not get 100% guaranteed service like circuit switching. So the advantage of circuit switching was there. It was guaranteed service, right? Whenever I dedicate something guaranteed, like our restaurant example in the textbook, whenever we don't guarantee, then there is a possibility not getting service 100% of the time. So that is the problem with packet switching. But before the problem, first let us know what is the percentage of not getting circuit life or 100% service. How we can get that? Using the
1 minus p.
using the binomial distribution. So p is 0.2, so 1 minus p will be 0.8. That means let us first see the interpretation. Okay, so now if I say, for example, our first question, what is the probability that a given user is transmitting and the remaining users are not transmitting? Now tell me, a user will either transmit or will not transmit. Is there any other option in this case?
No, sir.
So when there are only two possible outcomes, there is a name of the distribution. What is the name of the distribution? Bernoulli distribution, right?
Bernoulli. Yes, sir. Bernoulli.
Toss a coin, either head or tail. Only two possible options. So see, math is everywhere. We don't see, but math is everywhere. So you toss a coin, either head or tail. There is Bernoulli distribution. When it becomes binomial, when you do the toss for 10 times, right? So
Yes,
you
sir.
toss for 10, that n is 10, and out of 10 times, how many times head was there? That is R. So what is the probability of, out of 10 toss, what is the probability of 4 times tail? You can now use binomial distribution. So similarly, in our case, there are 15 users, but what is the probability of users getting more than 8, right? Only then our service is getting cut. More than 8 users, not all users will get 100% service. Is it clear to everyone?
Yes, sir.
Any question? So this is
Yes,
the logic.
sir.
If logic is clear, then the calculation is very, very simple. Okay, now the first question, I'll go gradually one by one. The first question is, we'll use the formula, but here says a given user is transmitting. So what will be the formula for C? Okay, actually for, I can write,
Before D.
for C to DE. These are common, okay? These things are common for C to E. Now, let us do C. For C, what will be the equation? Can I write like this? 0.2 to the power, what? 1, right?
Yes, sir.
And then into 0.8 to the power 15 minus 1. Is it correct?
Yes, sir. 15 minus 1 and minus R.
Right. So 14. Or I can write, I think it is much better understood. 14. So 0.2 to the power 1, 0.8 to the power 1. Now where that NCR gone? NCR. Where is that NCR gone? Because when you say a given specific, if I say, okay, out of this class, Shahadat is doing this, what is the probability? What is the value of NCR?
1.
1, sir.
1. If I specify, there is no NCR is actually 1 because there is no combination. I have fixed. If I say, okay, out there are 50 students. In fact, there are 55 students in that class. So anyone in this class, then what will be the value of NCR?
15C1.
55C1 in case of our case, 55C1,
Yes,
right? 55C1 means actually 55. Is it clear?
Yes, sir.
Yes, sir.
There are 55 ways because anyone out of the class. So in this example, we are using 15. Now, this question says, given a specific user, so we should use 1 here. So since there is 1, no need to write down. So you can find out, you can use your calculator, you can get the answer later. Just let me specify the logicals only. So C is clear, right? how C will change? If I change here, anyone among the 15 users is transmitting, but anyone, and then others are not transmitting, then what will be the change here?
So
There will be
14C1.
There will be 15, right? 15 into. Take some time. Is it okay? That means 15C1 will be there. 15C1 means actually 15. Right? But in this question, it says a given specific user. That's why it is not just, we don't need, we will put 1 there. So we get this answer. Okay, let me progress and then we can again come back with the question. Question number D, find the probability that at any given time, all 15 users are transmitting simultaneously. All 15 users. What will be the value?
15C15, sir.
Right, 15C15. So what is the value of 15C15? Actually 1, right?
225. Oh, 1. Yes, sir.
15C15 is again 1. But in this case, all 15 users, so it will be like this. And then 0.8 to the power what?
0.
Right?
Yes, sir.
So if you understand the logic, the calculation is very simple using calculator. Any confusion? All 15 users are transmitting. Now, if you understand E, I think you will understand everything. What it says? Now we need to compare our approach with what? Compare our approach with circuit switching. We want to show packet switching is better in terms of number of users, but we have to admit after a certain point, packet switching will suffer from delay. That means from not getting circuit-like guaranteed behavior or not getting 100% of service. We want to find out that point. In this example, any idea what will be that point? Number of users? More than 8, right?
8. Yes, sir.
When number of users more than 8, number of users less or equals to 8, still packet switching will get circuit-like behavior. Is it clear?
Yes, sir.
When number of users more than 8, then it will happen. Now, how can we relate that? Need to find out what is the probability that more than 8 users are transmitting. Get the probability and then comment on what this implies about the number of users supportable under circuit switching and packet switching. So after getting the result, okay, find your calculator, make your calculator on or use your PC. Number E, we need to find the answer. Now, what will be? This will be sum of 15C I 0.2 to the power I, then 0.8 to the power 15 minus I, right? You can write by pen and paper so that it will be understandable to you. Okay? So is it correct?
Sir, I এর range দিতে হবে না একটা?
Right, definitely. Some of these where I have to write
I greater
that.
than 8.
But you can use normal symbols, right? But I am just like this where I equals to what? 9 to
I greater than 8.
15, sir.
Yes, sir.
9 to 15, right?
9 to 15.
So you have to calculate 15C9, then 15C10, then 15C11, then up to 15C15. And in some modern calculators, I think you can also get the sum in a single step. But if it is not in a single step, you have to find out 9, 10, 11, 12, 13, 14, 15. That means 7 times. Please, someone do it for me. what is the result? Do it in the calculator and post the result in the message box.
স্যার একটা কোশ্চেন ছিল স্যার
Okay, Arpita. Okay. Okay, ask your question.
স্যার
What is the question?
8 less than I less than or equal 15 এবার যদি তাহলে কি হবে স্যার
Less than or equals to I, then you have to subtract from 1. Right? Sometimes what happens, we have to, for example, you have to find out sum of 0 to 13. For example, in this case, if I say in the question, okay, less than or equals to 13, that means 0 to 13, right? So what you can do in that case, find
yes,
out
sir.
14 and 15 and then subtract from 1, same thing. But in this case, since it is 9, so if you do from 0 to 8, you have to do 9 calculations. If you do it from 9 to 15, you have to do 7 calculations. So this is better.
Okay, sir.
Right, Rohim, very good. 0.00078. I think it is correct. Now, what it says, what it actually says to us. This says, if I omit the last digit 0008, okay, that means out of 10,000 times. So the answer is actually this is equals to 0.000. Let me put it simple. That means I can write it like this: 8 divided by 10,000, right? Is it correct?
Yes, sir. Yes, sir.
So see the explanation. Out of 10,000 times, 8 times I will not get 100% service. So is it acceptable? Well, what do you think? Is it acceptable to you? See, when we see a video in a very small screen in smartphone, we accept, right? But when you see
Sir,
in a
buffering
large
হবে।
LED TV, you will not accept. Buffering hobe, but it will be very, very less. 8 times out of 10,000 times. Can you think? Is it? It is
It's very
acceptable in
small,
one-
sir.
Very small. Now, see, the more interesting thing is how this changes. This is very small. But if you take, okay, not 15, if you take 50 users, how this will change? That is important. If you do it with 50 users, I think you will get not very much change. Probably this is 0008. If you take 50, maybe 0.008, maybe, or 004, maybe. I'm not sure. Still, that is acceptable. So see, from 15 to 50, you go, but definitely it is acceptable based on some threshold. So threshold depends on many things, that is we call quality of service. If the user not accepts that, that is one threshold, right? But I'm not going to there. Just if you move from 15 users to 50, you will see in case of this example where 20% of the time a user is actively transmitting, that means 80% of the time user is idle, you will see very little progress of that value. It is still should be acceptable. So that is the main advantage of packet switching, and that is why internet is growing tremendously for last 20-30 years. Still it is growing, and there is no restriction on number of users. Okay, but in case of Grameenphone, in case of Banglalink, I think they are every year they are getting new spectrum, but still you face that voice, all circuits are busy, right? But in case of internet, if your internet connection is okay, maybe you are getting less speed, but you are not restricted from using internet. So this example actually gives us some overview of that particular point, that packet switching supports theoretically unlimited. Maybe definitely unlimited is not a good choice, but that means it will support many more users compared to circuit switching. Now, any question? So
So
your
circuit switching
explanation you should write something like that I have explained. Okay.
So
Yes.
সার্কিট সুইচিং এ কি আরো যদি বেশি ইউজার সাপোর্ট করতে হয় তাহলে কি ইনফ্রাস্ট্রাকচার আরো অনেক বেশি বাড়াইতে হয়?
Not basically infrastructure, the spectrum, the bandwidth.
ব্যান্ডউইথ,
Right?
আচ্ছা
Right.
প্যাকেট সুইচিং এও তো সেম, শুধু ব্যান্ডউইথ বাড়ালেই চলে।
Packet switch bandwidth is different. Packet switch bandwidth is actually there is no dedicated resource. See, so if you dedicate, you have to have a fixed number of users. That is the main problem. If you want to use some channeling, you have to have fixed number. It doesn't matter how large bandwidth you have. Okay. In case of packet switching, you don't need to make it dedicated to the user. But what you hear, dedicated bandwidth from the ISP, that is a different thing. I am not going there now.
Yes, okay, sir.
Okay. But this is from the system point of view. Okay. There is, I think there are some example exercise questions in knowledge test, and there is one question here. You can practice, and then we can discuss later. But for the class test, I think if you understand this one, it will be fine. Okay, can we move to next topic now?
Yes, sir.
Okay. Okay, now we have covered up to section 1.3, and then again, just keep in mind, next class we will have a first class test online quiz that will be in the ELMS, and so everybody must ensure that you have no problem with ELMS. And today we'll cover two more sections, that is 1.4 and 1.5. These are also very important sections, but this is not included in first class test.
স্যার আমাদের যে অনলাইন এক্সামটা হবে স্যার ওইখানে কি স্যার স্কিপ অপশনটা থাকবে স্যার?
Skip, probably I think I will not make it sequential, so you can come back and forth, no problem.
এটা স্যার করলে ভালো হয়।
Okay, no problem.
ওকে, থ্যাংক ইউ স্যার।
Sir,
Yes.
so total marks will be 20, right?
Okay, good question. Total mark will be 20, but sometimes what I do, I take tests from maybe 23 or 24 or 25. So if someone gets more than 20, that extra 1, 2, 3 marks will be added to his or her account, and at the end of the trimester, I will add those in the assessment. This I said this extra credit. Okay, so because sometimes what happens, you missed one class test, or you did bad in one class test, you have some reasons, so extra credits is the only way to cover up that. I normally don't take makeups unless extremely exceptional reason. Okay, so extra credits, how extra credits will be counted out of 20. If I take a test out of 23, if you get 23, you will get 20 out of 20, and you will get 3 extra credit. Those 3 extra credit will be counted. So if we take 5 class tests, probably if you count, maybe around 12-15 extra credits will be there. Your extra credits will be recorded, and then 1/3 of accumulated marks, that means extra credit marks, will be added to your assessment. Assessment means class test, homework plus attendance. What is the percentage? 55%, right? But it will not be counted to midterm or final, keep in mind. So if you say, okay, I have got 20 out of 20, how that marks will be added? If someone gets 23 in one exam and someone gets, for example, 10 in another exam, then it will be 3 extra credits, and then your average will be what? 15, right? So
Yes, sir.
at the end of the trimester, those 1/3 marks will be added to your assessment. Is it clear? So in that case, you might get 23, 24 in your first class test, but think that the test will be out of 20, but extra marks you get will be added to your account. And that will be calculated at the end of the trimester, not within that class test, okay? Okay, now let us go to our section 1.4. Section 1.4, okay. So this is 1.3. Okay, section 1.4 actually deals with performance measurements. In our workbook, this is the section 1.4. And also the figures I am using also related to your textbook. So first of all, there are 3 parameters. There are 3 parameters, and when we say performance measurements, now we are concentrating on packet switching. See, we just left circuit switching, and for the rest of the course we are concentrating on packet switching based on internet. So these performance measurements are actually applicable to packet switching, and there are 3 parameters. One is delay, one is loss, and one is throughput. Definitely the less delay, performance will be better. The less number of packet lost, performance will be better. And throughput means actually the output rate. The more throughput, performance will be better. So let us see one by one. First one, delay. So when we say delay, what is the delay? Maybe transmitting data from end system to end system. But we need to go more in depth to know how those delays come from. For that, for one particular device, like in a router in this case, we are specifying all possible sources or packet delay for that particular node. So if there is another router, this cycle will be repeated. Okay, so for every device, this will be repeated. Now, how many sources? There are 4 sources of packet delay. First one, nodal processing. What is nodal processing? Whenever a packet is received by the device, it do some processing works. For example, what are possible examples? It checks error, right? A device checks error. If there is an error, discard. If there is no error, then router will decide, okay, to which interface I will forward the packet. This is also processing. So this type of processing takes some time. These are included in nodal processing. Number 1. Is it clear?
Yes, sir.
When you decide, okay, the packet will be forwarded to that particular link or that particular interface, then packet will be placed to that interface. In our example, see, there is a single interface here. So there is a single interface, but there could be some other interfaces, right? And when a packet is decided to place this interface, you can see there are already 3 packets here lined up. So you put the extra packet here. Like when you go to a bank, you go to a bank to pay your fees. Maybe there are 10 people in front of you, 10% in front of you. So you just wait to get service. Simply this waiting time is called queuing delay. It is very simple, I think. So queuing delay means the time a packet waits in the queue before getting service. The time you wait in the line before getting service in the bank. Okay. So second type of delay, queuing. Now, after the end of queuing delay, what happens? The packet is getting service. Now, what is the service? Service is a packet is a number of bytes, right? A number of bits. So each bit will be converted to signal. So the entire packet will be converted to signal and transmitted through the wire. So placing the entire packet in terms of bit by bit signals into the media, whether it is optical fiber or it is UTP or it is wireless, doesn't matter. This time of transmitting the entire packet into the media is called third one, transmitting delay. Now, what is transmitting delay? Let me write down here, okay? 4 sources of
delay.
Packet delay in a node. In a node.
Delay.
Okay. Then we'll find out how end-to-end delay come from. But for a particular node, one is nodal processing that contains like error checking or determining outgoing link, etc. So this contains the nodal processing delay. Then second one is queuing delay. Queuing. How? I think I
UE.
Okay, QUE. Okay, UE, double UE. Okay.
Yes.
UE, right. Queuing delay. Queuing delay means queuing delay. My keyboard giving problems sometimes. Okay, queuing delay, that is waiting time in the queue. Okay, then now come to third point, that is transmission delay. So transmission delay, that is transmitting the entire packet bit by bit. So it is generally we can call as in a formula, we can put in a formula L by R, where L indicates number of bits in the packet, or packet length, you can call packet length, and R indicates capacity of the link, that means bits per second. Okay, bits per second. So L will be bits, R will be bits per second, so it will be ultimately transmission delay will be what? Seconds unit. Now come back to our example again. After transmitting delay, now it seems that after transmitting all sources of delay finished, actually there is one more. When you put a particular signal in this point, how much time is needed to travel the signal to the next node depends on what? Propagation, but depends on what type of parameters.
Media.
Right, very good. Depends on the media. So if you put optical fiber, it will go fast. If you put UTP, little bit slower. If you put wireless, depends. So these actually represent the physical media. Now there will be one confusion, difference between transmission and propagation. Actually, transmission is putting a signal here, and propagation is one particular signal moving from this point to the entry of another device, that is the traversing the link. That is called propagation delay. How we can define propagation delay? So the last one will be propagation delay. Okay, so propagation delay is time needed for a single signal to move from one end of the link to the
Another.
to the other link. Okay, that is the entry of the secondary. So we can define this by D by S. Now what is D?
Distance, sir.
Right, distance. D will indicate distance, or you can, okay, distance, say distance.
Path of propagation.
You can tell this length of
Path
the
of propagation.
link, right, path of propagation or link, same thing. And S indicates what? Speed. Speed of
Transmission.
right, transmitting signal. So it depends. If you use optical fiber, that means it will be light path, right? If you use UTP, that will be electronic signal. So signal will be different for different type of media. But one interpretation here, see, LRDS, there is no common term. So transmission delay only depends on packet length, that is number of bits, and capacity. And propagation delay only depends on distance that travels, signal travels, and the speed of the signal. So 4 parameters, all are different parameters. There is nothing common. Now, if we just add all these values, then we can define total end-to-end. Sorry, not end-to-end. End-to-end is decided by number of nodes in the middle. So we don't know. It can be 2 nodes, it can be 20 nodes, but total nodal delay, that is delay in a particular node, will be this. Like if I define this T, it will be T processing delay plus T queuing delay plus T transmission delay plus T propagation delay. So processing and propagation similar. That's why I have just clarified processing and then propagation. So all these 4 types of delays, if we sum, then we get the total nodal delay. Okay. Any question? Okay, I think nodal processing and queuing delay will be very simple to understand, but one problem may be with transmission and propagation delay. So to make it clear, let us use figure 1.17, that is a caravan analogy. This caravan analogy means, caravan means a number of cars moving together. When you go to a program, when our VIP persons go, right, a number of vehicles move together. So why we use this example? Because this is similar to our packet. If you think about one single car, that is 1 bit. So 1 car is actually 1 bit, right?
Yes, sir.
And if you think about the entire caravan, okay, that means
It's
it
a
is
packet.
like a packet. So if you have like multiple caravan, then you can think about multiple packet. But to make our confusion clear between transmission and propagation, when, for example, there are 10 cars and you know toll booth, you know the procedure. I think all of us know the procedure. We have to pay and then there is a bar, and then when payment is complete, the bar actually opens and then the car moves, but one car at a time, not the entire caravan. So maybe there are possibly in this example that is described in the textbook. Just let me write down the parameters here. 20 second. Okay, let me write here. I think it will be better. So our caravan analogy. Sorry, caravan analogy, that is figure 1.17 from the textbook. Okay, so all the things are given there, but just let me make sure. Number of cars, 10 cars in the caravan, and then 20 second time for service time per car in the toll booth. Okay, in the toll booth. And there is other things I think given in the diagram. You can see here 100 kilometer. This is the distance between toll booth 1 and toll booth 2, 100 kilometer distance. Another information you have to know, that is speed, distance between toll booth 1 to toll booth 2 equals to 100 kilometer. Okay, 100 kilometer, and speed of car equals to, it is given 100 kilometer per hour. Okay, so these informations are given. In fact, this is L in our case. This is R, right?
Yes.
But we don't need L by R now, because if one car needs 20 seconds, 10 cars needs 200 seconds. Very simple. Distance, this is in our case D, and speed of car, this is in our case S. So what it says in the example, how much time will be needed from this caravan moving from toll booth 1 to toll booth 2. Okay, toll booth 1 to toll booth 2. So how can we get that? Okay, now another thing, there is nothing said about processing delay and queuing delay. So we can assume, even in any question, if you don't find anything about processing delay and queuing delay, you can safely assume those two delays are 0. Okay, so just to make our concept clear about transmission and propagation, we use only transmission delay and propagation delay here. So now the question is, what will be the total delay? So total delay means delay from toll booth 1 to toll booth 2. So if we say 0 is processing 0, not given. Okay, okay, let me make it clear, otherwise you'll be confused. So it will be T processing. Okay, it is given, nothing is given, so we can assume 0, TQ 0. Now it is 10. I am not using L now. 10 into 20, that is our T trans and then plus d by s. So d by s, that is our d propagation. Okay, so we can say, okay, that means equals to 200 second plus d by s means 100 divided by 100, right? Because both are 100. One is 100 kilometer, one is 100 kilometer per hour. So, but that is hour, right? So
Yes,
it will be 1 hour
200 seconds.
200 second. Okay, now unit doesn't matter. Okay, unit doesn't matter. Okay, so why there is only one Kerr's propagation delay we are calculating? That is the question. In case of transmission delay, we have multiplied by 20, but in case of propagation delay, where is that 20? Let me make it clear. Okay, is there any idea? Okay, when one car is out of toll booth, what is the time needed for that car from moving toll booth 1 to toll booth 2? 1 hour, right?
1 hour. Yes, sir.
Any question from anybody? So one car needs 1 hour. 10 cars need how many hours?
It's only need 1 hour.
That is the point, right? বানরের গল্প শুনছো না?
Yes, sir.
হ্যাঁ সেই রকম. So one car needs 1 hour. Actually 10 cars needs 1 hour. Then where is the gap? See, the second car just gets out of toll booth 1 20 seconds after the first car, right?
Yes, sir. Just 20 seconds.
So when first car reaches the toll booth 2, what is the time after which second car will reach toll booth 2?
20 seconds.
20 seconds. Is it clear to everybody? So that
Yes,
is the
sir.
point,
Yes, sir.
right? So that is the point. That is the difference between propagation. See, it doesn't matter how many cars in the caravan. It only matters the scenario of the road, the status of the road, right? Road jodi bhangachura hoy, time beshi lagbe. Road jodi khub smooth hoy, time kom lagbe. So cars speed actually depends on that. So that is the idea of propagation delay. If the media is faster, it will take less time. If the media is slower, it will take longer time, but it will not depend on number of packets. It will depend only one bit. So one signal travels using, for example, n second. That means all signals will travel using n seconds. So how that is actually counted, that extra, that is the transmission delay. So when you add 1 hour and then add that 200 seconds, then you have already counted those 10 cars. So see, transmission delay depends on number of bits, right?
Yes, sir.
And the capacity, but not on the length of the link and speed. And propagation delay depends on length of the link and speed, but not on the number of bits or capacity. Clear?
Yes, sir.
Yes, sir.
Okay. So that is about the first delay, first source of performance measurement. So this is the most, I think, time consuming. There are some examples. We'll do some examples after the exam in the next class. But main thing already done. And 2 other parameters, just let us finish the definition of 2 other parameters, then we'll do the example next class. So we'll complete 1.5 also in the next class. Time is almost running out. So the second parameter is packet loss. What is packet loss? Simply, whenever a packet is lost in the middle, doesn't matter in which node. Now, what are the possible sources of packet loss? So the second source of performance measurement, packet loss. How packet can be lost? One is
Media.
error, right?
Yes, sir.
One is error. Simply some data is actually changed. Error. But there is another way, that is buffer. Sorry. Buffer full. How buffer can be full? See here. Sorry, here. So when node send packets, packet is continuously arriving, and the processing or the transmission capability, transmission rate, it less than the arriving packet. In that case, what will happen? Packet will grow in the queue, right? So there will be a point where the buffer size, because buffer is limited in real world, memory is limited. So if continuously your arrival rate is more than your departure rate, that means queue will be full. Like in the bank, same thing. If customers are coming at a rate more than the service is given, there will be a time when the line will be full. So for example, it is lunch time, so they will not allow any more customers to enter. That means in that case, in networking, our packet will be lost because there is nowhere to store the packet. So that is another way packet can be lost. So two possible ways. One is error, one is packet loss. Okay, this is packet loss. And the last parameter is throughput. So throughput means what? Throughput means the rate at which we can transfer. For example, you get connection from the internet service provider. They said, okay, your connection is, for example, 5 Mbps. Do you get 5 Mbps always?
No, sir.
No. Even that also varies. Sometimes in the morning you get, okay, 2 Mbps. Maybe in the peak hour after the evening you get 1 Mbps.
Yes,
but most of the cases you don't get full 4 Mbps. There are many factors, but theoretically the real rate that we get is the throughput.
yes.
So maybe in the 10 a.m. in the morning you get one rate, 6 p.m. in the evening you get another rate. So there are two types of throughput. One is instantaneous, that is at a particular time, and another one is average. Because if you say, okay, my connection is 4 Mbps, it doesn't mean anything in the theoretical point of view. I want to know what actually you get. So if you say, okay, on the Wednesday morning I get 2 Mbps, that also adds very little information. If I say, okay, my monthly average is 1.5 Mbps, that is more representative. So we can take instantaneous throughput or we can take average throughput, and we can use average throughput for performance measurement. Okay, I think the examples we'll do in the next class. We are almost at the end of the class. So that is 1.4, and then after the exam tomorrow we'll start 1.5. So our chapter 1 will finish hopefully by next class. Any question?
No, sir.
Okay, let me call your names. Please respond as alert. Okay, Abdullah Al Rifat.
Yes, sir.
Inamul Haq.
Present, sir.
Imam Reza.
Present, sir.
Rukunuzzaman.
Yes, sir.
Laila Ishraq. Farah Farzana.
Present, sir.
Yes, sir.
Laila present.
Yes, sir.
Farah present.
Yes, sir.
Okay. Fazle Rabbi.
Yes, sir.
Priyabrata Nath. Ifat Haq.
Present, sir.
Ali Ahmed.
Present, sir.
Oshik Devdas.
Yes, sir.
Khurshida Jahan.
Sir, Ali Ahmed present.
Ali Ahmed. Okay, present. Yes. খুরশিদা জাহান, সামির আহমেদ, মাহমুদুল হাসান,
Present, sir.
ফাহিম শাকিল, আবু সাজ্জাদ,
Present,
নিবির,
sir.
আবু সাজ্জাদ প্রেজেন্ট।
জি স্যার।
ওকে, নিবিরুজ্জামান,
স্যার
সাদমান
মাইকের
সাকিব।
সমস্যা স্যার ওর।
Yes, sir.
ওকে, নিবিরুজ্জামান প্রেজেন্ট। ওকে, সাদমান সাকিব প্রেজেন্ট, আদনান কবির,
Yes, sir.
তাকি ইয়াসির প্রেজেন্ট, শাহাদাত হোসেন প্রেজেন্ট, রাকিবুল ইসলাম,
Yes, sir.
ওকে, আল শাহরিয়ার,
Yes, sir.
তানভীর হাসান, সাকিব,
Yes, sir.
তানভীর হাসান প্রেজেন্ট।
জি স্যার।
ওকে, সাকিব হোসেন,
Yes, sir.
মাসুক আলম,
Yes, sir.
সাব্বির সরকার,
Yes, sir.
আবির সাদিক, আবরার সাদিক, সরি,
Yes, sir.
ইশতিয়াক আহমেদ,
Present, sir.
আব্দুল্লাহ আল মফিল,
Present, sir.
মাহফুজুর রহমান সিফাত প্রেজেন্ট, শফিকুল ইসলাম নীরব, আমান্তা হোসেন,
Present, sir.
আবির রেজা,
Present, sir.
খালিদ রিদওয়ান, শাহরিয়াজ,
Present, sir.
তাহমিনা তানজিন, মাহফুজুর রহমান, মোহাম্মদ মাহফুজুর রহমান, ওকে, ফাজিলা নবী,
Present, sir.
আশরাফুন নাহার প্রেজেন্ট, শিফাত চৌধুরী,
Yes, sir. Yes, sir.
মেজবাউল আলম,
Yes, sir.
ইয়াসির আরাফাত প্রেজেন্ট, সুদীপ সরকার,
Present, sir.
আব্দুর রহিম প্রেজেন্ট, মিরাজ ফারুক, আবু আব্দুল্লাহ, খন্দকার শ্রাবণ,
Yes, sir.
শাহ আলম,
Yes, sir.
ইমতিয়াজ হোসেন,
Present, sir.
রিফাজ নাহিয়ান।
Yes, sir. Present.
Okay. Then I think those not registered yet. Bidhan, okay. I got your ID. Abu Kibriya ID. Nibirujjaman, okay. Abdur Rahim, okay. Anyone else? Dihan Pathan, put your ID and name in
আমার
the.
একটা কোশ্চেন ছিল স্যার।
Sorry, Dihan.
স্যার লেট রেজিস্ট্রেশন আর কি স্যার, আমি কালকে
Okay, no problem. Put your ID and name.
present, sir.
Samir Ahmed. What's the ID? ID
162071.
Samir 162 071 Samir Ahmed. Okay. Present. Okay, question. Who has the question? Who has this? Who asked
স্যার
the
নেক্সট
question?
ক্লাসে তো স্যার সিটি হচ্ছে স্যার, এটা কি মাল্টিপল চয়েস স্যার?
Yes, multiple choice. Okay, I have put the type of questions in the outline text. Okay, multiple choice, matching, true, false, and there can be one or two short questions, but maximum you have to write down maximum 2, 3, or 4 lines of text maximum. Okay, so thank you very much. Let us finish today.
কোনো ম্যাথস থাকবে?
Yes, it can be. There can be some. Okay, I will upload video. Okay, there can be some numerical problems, but in that case, maybe what can happen? You have multiple choice question with numerical problem. You do your rough in the page, okay, and then choose the correct answer. So there can be that type of.
ওকে স্যার।
You don't need to show the calculation in the question. Okay. Okay, any other question? Okay, thank you very much. See you in the next class.